With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. Figure shows a rough track, a portion of which is in the form of cylinder of radius r. With what minimum linear speed should the sphere of radius r set rolling on the horizontal path so that it completely goes around the circle on the cylinder path? So this is the diagram if you see here. So we want this minimum velocity v0 that the particle should be given here so that it completes the circle. So the maximum probability of the particle, the cylinder, to leave the track is here. So let's say it reaches to this position with some velocity v dash. So the particle is performing pure rolling, so it will be having the point of contact velocity 0. So to have point of contact velocity 0, it must have omega r and v0 related like this. So we'll write v0 equals to omega r, right? So at every point the angular velocity and linear velocity will be related like this, right? So at any instant if I write the kinetic energy of the particle, so that will be translational plus rotational, right? So translational we know that half mv square, and rotational we write here 2 by 5 mr square is the moment of inertia by 2 into omega square. Since we know that the rotational kinetic energy is half I omega square, so I is this for sphere. So if you see here, this is 2 by 10, omega square is v square by r square. So if I put the value, I will get half mv square plus 2 by 10 mv square, right? So we get here 5 by 10 plus 2 by 10 is 7 by 10 will be the kinetic energy of the particle at any instant, right? At any instant of the path, the kinetic energy will be this, right? So if you see the particle, if the particle reaches here and here, just the normal reaction becomes 0, since we want the minimum linear speed. So to have minimum linear speed at this position, we will make the normal reaction at this position just equals to 0. So here the mg will act as a centripetal force, right? So I will write, let's say is point P. So at point P I will write the mg is only acting as the centripetal force, so that will be mv dash square by r, right? Where r is the radius of this circle, right? So if you see, the radius of the circle will be r minus r, right? If you see here, this is the smaller radius here, and the radius, the center of this is here, and the center of this path is at a distance of this, right? So it will be r minus r, and this is smaller, right? So this will be the centripetal force. So we will write here m v dash square is equals to mg r minus r. So this is the equation 1. Now we want the v0, right? So let's apply the work energy theorem to get the relation between v dash and v0. So we'll write here work energy theorem from this point O to this point P, right? So from O to P we are applying work energy theorem. So we'll write here work done by all forces is equals to change in kinetic energy. So here the only force who is doing the work is mg. Now if you see the distance traveled in the direction of gravitational force is this, that is 2 times of r minus r, right? It's if I take the displacement of the center of mass of the sphere, so 2 times of r minus r. So I will write mg r minus r with a negative sign, since gravitational force is acting downward and displacement is in upward, right, is equals to change in kinetic energy. So change in kinetic energy is what? Final minus initial. So we already calculated the expression for kinetic energy is 7 by 10 v square. So I will write 7 by 10 m. V dash is the final velocity and v naught is the initial velocity, right? And here this. Very simple. So we already calculated the v dash m, v dash square is this, right? So if you put the value of v dash square, you can cut this m, and from here you will get the v naught square is equals to, yeah, I send this v naught square here, and multiplying this 10 by 7 to this, so I will write 20 by 7 g r minus r, right, and plus v dash square. So this will be the v naught square value. Now we can put the value of v dash square. So if you see here, the v dash square is this, right? So v dash square is g r minus r, right? So just put the value here. So I will write 20 by 7 g r minus r, and v dash square is simply g r minus r. So if you add the two, you will get the value of v naught square as 27 by 7 into g r minus r. Very simple. Now v naught will be equals to under root of 27 by 7 g r minus r. And this will be the minimum velocity with which the sphere, if the sphere is projected, it will complete the vertical circle. And our answer. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.